Hey guys, welcome back. So today, working on this Generac XD5000e. This is actually a diesel powered portable generator, which I didn't know Generac made. I've actually never seen one of these before. Powering it is an L100 Yanmar diesel engine, which for the most part is complete. We are missing the airbox cover, but thankfully we do have a filter, so likely the engine's in good shape. But that is to be determined because this comes to us in non-running condition. This was actually welded to a tugboat and used out at sea, and it recently stopped running at about 546 hours. So the Captain Phil, dropped this off, asking if we could go through it and determine what the issue is, and if we're lucky, get it running again. So let me set up a little bit better and get going on this. So first things first, let's check the oil. Make sure we have some. When dropping this off, he mentioned that this machine is in need of a good service, meaning a new filter and oil. And yeah, we have plenty of oil, but it is well used. Definitely needs to be changed. But until we know that this machine runs and makes power, we're going to hold off on the oil change. But you can tell someone was trying to start this. This is in the run position. Mechanism seems to work okay. This is the wire for the oil pressure switch. We also have one here for the fuel solenoid. So, those are all plugged in, but, being at sea, corrosion could definitely be a factor here. Pretty interesting ad here. So this is like a purge bulb that you would see on a boat tank. And that actually is going to pull fuel from the tank right to the injector and then back up the return line, which is the same line that the injector return is connected to. We also have a decompression lever right here. So right now it's at full compression. So let's turn the engine over by hand, make sure it rotates, and see how the compression feels. All right, so the engine, it does rotate. Recoil, though, isn't consistently engaging. And the compression, it's there, but it feels pretty weak. And when you consider the decompression mechanism is disengaged, this should be nearly impossible to turn over. So we might have low compression, high leak down, and unfortunately my compression tester and leak down tester, they're not going to fit in a diesel. But based on the feel, we could have engine issues here. So let's actually get a battery on this. We'll try to crank it with the electric start, see if that works. So we'll get the battery mounted in a minute. We have the leads right here that kind of zip tied out of the way. So we'll cut that zip tie and get the battery installed. But one other thing I'm noticing over here is that we do have potentially some wiring issues. We have a wire nut, which is connecting this green wire to a red, and the red, it's not going anywhere. But based on the length, looks like it should go over there to that harness. And just judging by what I see on the remaining wires, there does appear to be some green crusties. So yeah, that could be an issue. But this here, I believe it is used for charging. Not only that, though, it might power the fuel solenoid and the oil sensor and some other electronics. So without that, that could definitely cause a run issue. So we're going to leave it as is for now. We'll get the battery installed and see if the engine at least cranks, as it is right now. And there is a fair amount of corrosion on this battery lead end, and it actually looks like might be broken. Yeah, it is broken. So we should get that replaced, I think, before connecting up the battery. And the negative looks better. At least it's not broken. So we can clean that one up. I think that one's good. But this one for sure needs to be replaced. So for now, we're just going to use the new terminal here on the battery positive. We'll use the old on the negative. You know, that one might need to be replaced as well. I guess my concern is, you know, these cables are pretty short as they are, and we don't really know if this machine's any good based on the fact it doesn't run. So we're going to just do what we need to get it to crank and hopefully run, and then we can circle back on anything needed to make it better. All right, passes the spark test. We don't have any shorts. So we'll get that secured, and we'll crank the engine. See if it works, see what it sounds like, and who knows, maybe it'll start. All right, so we'll give this a quick try. I do have the main breaker off, voltage selector off in case it starts. But right now, the engine switch, it is in the off position. So I'm going to click it one click into the run position. And, you know, I would expect to hear maybe the fuel solenoid click, but I don't. So that is not a good sign. Let's try engaging the starter. And we get nothing. So no signs of life from the electric start. So I'm willing to bet the issue is that wire right there. So we're going to use the multimeter to test that wire. I've got one lead connected on battery negative. And if this is a positive wire that's energized, we should see voltage, but I'm not seeing it. So let me walk to the other side of the machine. I'm going to hit the start button, which should crank the engine. And keep an eye on this meter. Let me know if we get any voltage. And we got nothing. So I'm going to move the lead from battery negative to battery positive. And we're still not showing any voltage. Let's try cranking the engine again. Potentially it's a switched ground. All right, we did get voltage here. So I had the leads reversed, which is why it showed a negative. But this is actually a switched ground wire. So the green color here kind of makes sense. The red, not so much. So clearly, you know, someone's been in here before getting this to work, and that repair, I would say, failed. So let's see if we can get the voltage regulator out of the way. You know, I think that will expose the wire harness in question, and we can take a closer look at it and see what we need to do to get it repaired. Okay, yeah, and it's just a harness hiding behind this regulator. So it does look like the regulator has actually 3 wires going into it, and the red wire goes up to the starter solenoid. So yeah, it looks like we have one more fastener, maybe 2, holding this in place. So let's get those removed. But first, let's disconnect the battery negative lead so we don't risk shorting anything out. You know, some of those wires are likely live. And these are just screws, so maybe JIS screws at that. So we're going to try the JIS screwdriver, and it is turning, surprisingly. You know, given the amount of corrosion, don't want to take apart anything that we don't need to here. Ooh, lots of green crusties in there. So yeah, definitely a case of the green crusties. You know, the worst one there in your top left, that is the one with the missing wire. So, you know, I guess we could just reconnect that wire and theoretically we'd be good to go. But we also have issues here on this connector. So yeah, these pins, they're not in great shape. And the thing that doesn't make sense is that the missing wire out of this connector we found was a switched ground. And that connects in over here to the white wire, which runs down to the regulator. And that is actually doubled up with this, which is actually full-time battery positive, connected right here, fed in from the red wire on the battery. So if we were to connect this, you know, as it appears like it should be, we would create a short, potentially blowing out the regulator and also blowing out the fuse. So yeah, something doesn't seem right here. So let's actually check the fuse. Let's see if it's any good. You know, clearly someone was doing something here that wasn't quite right. And I was also told this regulator is not new. So potentially the wiring or the pinout on this connector isn't compatible with this machine. So I've got the multimeter set to test continuity. Let's test across the leads on the fuse, see if it's any good. And yeah, surprisingly, that fuse is not blown. So let's verify these wires here. This red one runs up to the starter solenoid, that is the trigger wire. That should be positive when we hit start, which translates into this black wire right here, which again, wire color doesn't make sense, but they usually don't make sense. So I'm going to put that spade in. We're going to get the meter on there and get the battery reconnected. We'll try cranking the engine and just make sure we get voltage out where we expect it on that connector. All right, we're in the run position, no voltage. Let's push and hold start. And no voltage, at least no positive voltage. So yeah, that is interesting. Let's reverse the leads and we'll move the negative over here, put the positive on the battery. And we are showing some voltage now, so 12.47. So that would imply that this is a negative. Let's hit the switch. And interesting. So it does go to battery voltage when I push and hold the switch. But when I let go, it goes to 12.47. I would expect that to be 0. And even in the off position, we still have a ground there. So yeah, we might have a problem with the switch, but it would appear that the solenoid is a negative switched solenoid. So that leaves us with two other wires here. We have the yellow, or maybe that's white, that goes into the green, that goes to the voltage regulator. So I'm not sure exactly what that would be, but let's put a lead in there and test that. And we have, looks like a ground connection full time, because that switch is off. So we got it in the on position, start position, so no change. So the white wire appears to be full-time ground. And that just leaves us with the red, which is the yellow that goes into the voltage regulator. So let's see where that goes. And we're showing a tiny bit of voltage. Let's put it in the run position, then we'll try start. So yeah, we don't really seem to get much out of that, so we need to do some more digging to find out what these wires really do. So luckily these have been out before, and they're not tight. So I would say this has been off recently. But the good news is at least these are not rusted in place. So once we have this opened up, we can trace those 4 wires and see exactly where they go. And it's my understanding too that this was hardwired at one point to the tugboat, and that wiring was undone and the original factory wiring restored. So it might be a little scary in here. Oh, one more screw. Actually, doesn't look too bad. Well, it's a good thing we opened this up. You know, some of the wires we were testing were actually going through a relay, and that could have sent us down the rabbit hole chasing things that didn't exist. So the testing we did down there, I wouldn't say is completely null and void, but it's definitely suspect. Anyway, this is the harness right here coming up, the one in question. And the green wire, that's the one that gets spliced into the red. And then ultimately the white wire, which is connected directly to battery positive. So although it's green, this is full-time battery positive, and it goes right into the switch right here, which has 3 terminals here on the right side and 2 on your left. Now, I think the way this works is that we have probably a normally open and closed position based on kind of the position of the switch here. So right now it's in the off position. So I'm going to check these leads here on the left in the off position to see where we have continuity. And we do have continuity between the middle contact and the one here that's not used on the right. Let's try the center to the bottom, which actually jumpers over here and is bare. So we can test from here to here. And we don't have a tone, but if I put this into the run position, we now have a tone. So putting it in the run position connects the middle terminal to the bottom one. And I suspect the same over here. So let's see. We're in the run position right now. And actually, we don't have anything. Let's try the off position. Still nothing. Back to run. Nothing. Let's try clicking it to start. And still nothing. So, yeah, potentially I don't have a good connection here. So back in the run position. And let's try start again. Okay, there we go. So these wires are connected to crank the engine, and when in the run position, the green on the middle post is connected to the green on the lower post. So with that in mind, you know, that is likely going to energize the relay. And we also have, you know, when cranking the engine, we now know purple is the one that should crank the engine, but I don't remember seeing a purple down on the other side. So let's take a look at that real quick. All right, so this one I misinterpreted. This is actually the purple wire. Looks kind of black, but it's kind of making sense now. So we know the green is full-time power because that is connected in to the white, which is ultimately connected to the battery through the fuse. So the power goes up the green. When you hit start, it comes down on the purple, and that goes over to the red wire, which runs right up to the trigger. So that all makes sense. So that just leaves us with the orange and the white. So let's track the white. The white is connected to the green, which runs into the bridge rectifier. So let's see where that goes. So it looks like the white wire actually comes up to the relay and is on pin 30. So this is the power input to the relay, and the red wires are the outputs. So one wire actually goes to the fuel solenoid, the other one goes down to the voltage regulator, and depending upon whether the relay is energized or not determines where the power goes. Now, things do get a little complicated, but the control side is on the right and left. So we have this gray wire that actually runs over to the oil pressure switch. So this is grounded only when there's no oil pressure energizing the coil, assuming that the other side must be positive, which is the green in this case. And if we follow it over, we do see that, power comes into the middle terminal, and when in the run position, we know that power gets passed over here. So when there's a low oil event, this relay energizes and likely kills fuel to the system. So yeah, everything here seems to be checking out. Really the most important wires were the power coming up, which didn't seem right that it was green, but it seems like that is correct, and the purple, which is to crank the engine. So the white does appear to be also a power wire. And the last wire, I don't think we need to trace, but that is actually, looks like power coming out of the relay. So let's fix the wiring issues on the other side, get this resecured, and I'm willing to bet the engine will crank. So let's start with the red wire here. This is the trigger wire for the starter. And there's really no reason to run it through this harness. It can be unplugged directly from the start solenoid. So we're going to butt connect this directly to the purple wire. And we'll also use some shrink tubing to help make a good seal. The wire gauges, they are a little different, so I'm hoping that we can get away with using this butt connector, because butt connectors, they do expect not exactly the same size, but similar. If the size of the wire is different by too much on each side, then you could run into issues getting it to hold. That appears good. And next, we'll connect up the full-time battery positive, which is the white wire. So we'll get that stripped back, and that will be fused through here. But this one I'm not going to permanently connect. I'm going to use, I think, a spade connector and some dielectric grease, which I don't currently have, so I'm going to have to order some up. But we can circle back later and get the grease in the spade connector just to help it survive marine conditions a little bit better. And this wire, it's always going to be live when the battery's connected. So we're going to use a female spade on this side, so if it ever comes unplugged, it can't short anything out. That's good. And actually, I think I misspoke a second ago. So it's the green wire that is full-time battery positive. So we want to connect that one up to the white. And it might actually be too short. We had that red jumper before. I mean, theoretically, it should be long enough just. So let's add the male connector to that wire. Okay, and just 2 wires left. So we've got the red and the white. And we determined the white is going to have power coming down when the machine is in the run position. So we're going to put a female spade connector on that one. And the white was connected to the green, so we'll put a male connector on that one. And last one, we get the yellow. So the yellow connects to the red. And always check the connections. Make sure they're crimped on well. But at this point, this engine should theoretically crank. So I'm going to resecure the voltage regulator, get the battery reconnected, and see what we get. Let's do the tap test, make sure we don't have a short. Okay, and no spark, so that is a good sign. Another good sign is that I hear the relay energizing. So, good. Let's get the control panel resecured. We'll resecure or reconnect the battery negative. Then we'll try to crank the engine. So I'm going to try this real quick. Don't want it to actually start yet because I got to clear the bench. But let's make sure the starter engages. And it does. So let's clear the bench, try to get this thing started. So we'll set this voltage selector in the 120/240 mode. Main circuit breaker on. We've got the kilowatt plugged in and a light plugged in and turned on. I've also added a multimeter connected to the battery, so we're starting at 12.74 volts. And if the voltage regulator is working, we should see this charging somewhere in the 13 to 14 volt range. So let's crank the engine, see if it starts, and if it makes power. All right, so there's a fuel valve right there. You know, if this thing decides to run away, we can shut it off, but it's going to take a minute to run out of fuel. So I did also pull the air filter off so we could try to jam a rag in there just in case, but being a diesel, there is no easy way to shut this down if it decides to run away. So let's hope it doesn't. Contact. All right, so we're looking pretty good here. The engine started, sounded good, generator's making power, and the battery was also charging. So everything seems to be working, and the engine, now that it's run, the compression came up quite a bit. You know, on the compression stroke, before we had a lot of leak down, and now we have very little. So I don't think we have any issues with the Yanmar engine. The generator, though, different story. You know, we were only at 100 volts, so the voltage is low, and likely this is a brushless machine with a bad capacitor. So let's get the end cover off and test that capacitor. And the really interesting thing is that, you know, despite being a Generac, we have a Yanmar engine, and this generator looks to be a Winco, or at least a clone of it. So to get the end cap off, there's actually a bolt, I think, on each side we need to loosen up. The cover should twist counterclockwise, and then we should be able to pull it off, giving us access to the capacitor. So hopefully this isn't rusted in place. It's turning. Doesn't feel good though. Yeah, it doesn't feel good at all. Not sure if it broke or if it's coming out, but it suddenly got a lot easier. And I don't actually see it spinning out. Yeah, that might be broken. Not sure. Let's try the other side. And interesting. That one's just spinning too, so not sure what to think of that. But it is loose, at least on the left side. And looks like we can get the cover off now. Yeah, and that capacitor doesn't look great. And the good news is it looks like it's a captured nut of some sort, so I don't think we actually broke anything. Capacitor, though, definitely been in there, I'd say, since new. So let's cut the zip tie out. And actually, we can probably test it like it is, but given we're low on voltage, I'm thinking we're going to have to replace it. So let's cut the zip tie, pull it out, and test it. Yeah, it's kind of hard to see, but looks like this was or is a 25 microfarad capacitor. So it is plus or minus 5%. So that puts us, I'd say between 24 and 26 microfarad would be considered good. And 23 to 27 would be just a little bit out of spec. So let's see where this one comes in at. And yeah, we're out of spec at 19.6. So yeah, we need a new capacitor to fix the voltage problem. So I do have capacitors. I guess the question is, will any of them work? And I can see right away, we do have a 25 microfarad capacitor. Now, the form factor, it's a little bit shorter and fatter. I'm not sure if that's going to be an issue. We also have this one right here, which is 10 microfarads, so that is not going to work. We got a 30, and actually this is one from the Campbell Hausfeld generator that we worked on. That one is 31, so not the right spec. Same thing there. And we got a 50, a 35, and looks like a 20. So yeah, this one should work. I guess the question is, will the uncover fit with this in place? And actually, they are the same diameter. The only difference is that the new one is a little bit shorter, so that should not be an issue. It'll fit. Let's just double check this one, make sure it tests well. This one's also plus or minus 5%, and look at that. We're exactly at 25 microfarads. So let's get this one installed, fire the machine back up. Polarity doesn't matter on this. This is essentially a run capacitor, the same that you'd have on an HVAC system. So that is connected. Let's get a new zip tie in there. Okay, let's start it again. I'm going to leave the end cover off, make sure the voltage is corrected. All right, let's try it again, see if the voltage came up any. And that was it. So the new capacitor now has the machine running at almost exactly 120 volts. So at this point, I think it's safe to get the uncover back on. So at this point, I think we're going to pause the video. I do need to place an order, get some tune-up items, and we're going to need some new diesel oil, new air filter, new fuel filter, and likely some dielectric grease. So yeah, let me place that order, and in a week or so, we'll finish this up. Well, it's been a while, and we finally have, I think, all the parts we need to finish this up. So we have some OEM Yanmar parts, including a new filter and air box. We also have some Rotilla T6, dielectric grease, fuel filter, and an oil screen. So let's start with the air filter. We'll finish up the rest, and then we can get this outside and put it to the test. So we're going to start just by getting this air box cleaned up a bit. It's covered with a bunch of oil, and really the whole machine is. I'm tempted to clean it all off, but the oil, that's really the only protection it has against the salt. So I think we'd be doing it more harm than good to actually clean it off the engine and the generator. So we're just going to clean up the air box, make sure it's filtering air and only allowing clean air in. But the rest of it, we're probably going to leave with that protective coating. Interesting. So the airbox cover, it fits, but the stud seems like it's too short. There's just no threads to grab. So yeah, potentially I ordered the wrong cover. Okay, there we go. At least the left side popped in, so it's just a matter of getting it in the right spot. Yeah, we might clean this blower housing a bit. Seems to be handling the salt just fine, although I say we'll clean it up a bit. But I don't think WD-40 is going to do it. Let's try something a little stronger. And next we'll get some dielectric grease in here. So the local automotive store had this nice spray can of CRC dielectric grease, although I just tried spraying it and it's a little bit less like grease and a little more like a liquid, which I'm not sure how I feel about that. I think a grease would have been better. But according to the bottle, this is dielectric grease, but you can see it just kind of pours out of there. So I'm guessing that's just to deliver it and that is going to evaporate off and just leave the grease behind. And I think next we'll get this filter swapped out. It's actually in pretty good condition, but it's actually on backwards. And at this point, you can't really switch it around the right way because any sediment that was caught is now going to go right into the fuel system, which you definitely don't want on a diesel. You don't want to clog up the pump. And yes, fuel clamps not playing nice. Let's try the other side. And kind of the same thing. These clamps are actually a little bit too small for this line. So when you give it a squeeze to release the tension, it doesn't really take off much. So we're probably going to swap those out. They are starting to rust up anyway. So we're free on this side. Fuel valve on the tank is shut off. So let's separate that. Yeah, I think rather than draining this, we'll just cap it off. And we have to be careful here on the other side. The tank has a rubber bushing, so we don't want to pull that out, or we're going to have a massive fuel leak. Yeah, potentially an oversight on my part. You know, I assumed this was 1/4 inch line, but it might actually be 5/16. But I'm hoping it is 1/4 inch and just stretched out. So I'm going to disconnect it here at the T, and we'll see what size that T is. Yeah, I think it is 1/4 inch. That line likely was just stretched out. So we're going to get a new fresh piece of line, some new clamps, and I think we'll be in business here. So we'll get this filter on the correct way. So we need to get the air out of the system. So I'm going to turn the fuel valve on, and we're going to use this purge bulb up above to suck the air out and pull the fuel through. All right, and that is good. I can now hear the fuel returning to the tank. Perfect. And before we go any further and change the oil, I do want to get the engine started again. and just make sure that the air we introduced isn't going to cause a problem. And I also want to build up some heat in that engine before changing that oil out. All right, no issues at all with the fuel system. So we're going to drain the oil, and I'm going to use a zip tie to help keep this hose hopefully in a good spot. And these drain tubes, not a big fan of them because it takes a long time usually for the oil to come out. But I do want to see what it looks like. So we're going to drain it into the pan and have a look at it. And yeah, this is going to take forever, but you can see from the oil, I mean, it is well-used oil, but fairly typical looking for diesel. You know, I don't see any metallic, no glitter. So the engine, it would appear to be in good health. So to speed this up a bit, I'm going to use the siphon, and we'll just siphon out the rest through the oil fill. All right, and this here, it is an oil screen, so I've got a new one of those. So I'm just going to clean up around the old one, see if we can get that bolt out, and get that screen changed out. And this should just pull out. But there is an O-ring, so you gotta twist it and pull. And yeah, it's a good thing we're doing that. This screen definitely has some debris on it. You know, that right there. Well, it kind of looks like metal, but it doesn't feel like it. So there is some sort of contamination there. But yeah, with the screen kind of plugged like it is, it would have been restricting oil flow for sure. So we'll get the new one installed and top it off. And it looks like that filled it right up to the last thread. So yeah, we are filled perfectly. And I think the last thing we're going to do here is check the valves. But all that's going to depend on these bolts. They don't look happy. And as of right now, I don't hear any signs of a valve issue, but if we can check the valves, you know, I'd like to. while we're here. Okay, we got one. Yeah, not sure about that one. Yeah, that one isn't moving either, so let's try a wrench. Okay, that one does turn, so we're good there. Okay, and that one's turning as well. Good. All right, so that cover came off nice and clean. The intake actually looks like it's open right now, so we can check and set the exhaust. And there is some clearance in there. I can wiggle that. Now, Yanmar has a pretty generous spec on this, anywhere between 6 and 10 thousandths of an inch. So let's start with a 6. And that slides in with no drag. How about an 8? And no drag on the 8. Let's see how the 10 fits. Yeah, and really no drag on the 10. So we're out of spec on that exhaust. And we need to set it. But let's just keep going. Let's see where it's at right now before we do anything else. Let's check 12. And a 12 doesn't fit. So we're probably just out of spec at about 11 thousandths of an inch. So that's not too bad. But we do need to close that up closer to an 8. So we'll double check the 8. And just a tiny bit of drag. So it's likely at 9. Let's check that. And yeah, a lot of drag with the 9. So the exhaust is now good. Let's check and set the intake. All right, let's start on the low side of the spec, which is 6 thousandths of an inch. And yeah, that goes in without any drag. So let's try middle of the spec at 8 thousandths. And no drag on the 8. Let's try a 10. And a 10 does not fit. So likely we're a 9. And yeah, it's a snug 9. So we're somewhere, I would say, between 8 and 9 thousandths. So the intake is actually perfect. No need to adjust that. Well, we got the machine outside and we are pretty much ready to go. So I'm sure my neighbors are going to love this one because these are very loud. You know, these diesel engines are not known for being quiet. And usually at this point in the video, I have to turn the microphone down about 10 decibels to avoid clipping. And for these engines, have to turn it down, I would say at least 15 to 20 decibels. So just to put a number to that, I also broke out the decibel meter. So we'll measure the output in decibels, both under no load as well as full load. So let's get the engine started. While it's warming up, we'll double check the output using the kilowatt to measure the voltage and the frequency. We use the amp probe to measure the total harmonic distortion in the oscilloscope to see what the waveform looks like. If everything checks out, we'll put on a half load of 2500 watts, and then after a couple minutes, we'll go for the max of 5000 watts. And just for reference, with the machine turned off, we're starting at about 37, maybe 38 decibels. And one more thing worthy of note before we get the engine started. You know, I use a directional microphone when doing the load test, and it's pointed right at me. So that is the only reason you can hear me when testing these machines. You know, if I remember right, the last diesel I tested, you know, despite the microphone pointing at me, it was still overwhelmed with the amount of sound. And as a result, you could barely make out what I was saying. So that could happen again. Guess we'll find out. So as you can see, without a load, we're pretty noisy at about 73 decibels. You know, otherwise, you know, things are running just fine. It started up without issue. Engine speed and voltage was a little low, but that has since come up as the engine has warmed up. So we're now actually at pretty much exactly 120 volts and 60.3 hertz. So that is very good. The THD also decent at 4.3%. So this, I'm hoping, is a low THD machine, and I would say we're off to a good start. Sine wave looks decent for a brushless machine. So let's put on a half load, starting with 2000 watts. No issues. 2500 watts. So yeah, no issues at 2500 watts at half load. THD mostly unchanged at 4.2%, and the sine wave may have cleaned up a little bit. So let's give this a few minutes. If everything checks out, we'll go for the max of 5000 watts. And at half load, the sound came up a bit to 74 decibels. All right, it's been a few minutes at half load, no issues at all. The engine speed, though, we have to keep an eye on. It is just below 58 hertz. You know, ideally it would stay above 57. And a diesel has lots of torque, so it should be able to do it. At least that's my hope. So let's swap the 500 for 1000. Now we're at 3000 watts, 4000 watts. No issues. Let's go to 4500. Yeah, we're losing speed, so I don't think we're going to make it to 5000, but we can try. Let's try 5000. And yeah, it's doing it, but the engine speed's pretty slow at about 55 hertz, so it is down on power. But let's to say, let's leave it there, but I'm going to take 500 off, and that puts us into a safer range. So at 4,500 watts, THD remains very low at 4.5%, and the sine wave looks cleaner, although the voltage may have come down a bit. So let's give this a few minutes and make sure there are no surprises. And surprisingly, at 4,500 watts, sound level may have gone down a little bit. We're at 73 decibels. Well, it's been a few minutes and no issues at all pulling 4,500 watts. Of course, we are falling short by about 500 watts. I mean, technically, it can do it, but as it is right now, we're kind of at the limit, both on the voltage and the engine speed. We're at 113 volts, a little bit below 57 hertz, and the 113 and the 57, those are the safe cutoff points. So, yeah, 4,500 watts, I think, is about all this machine can do. So, let's take the load off. We'll give both the engine and the load bay a chance to cool down. So I'm noticing, I guess, two things while I'm waiting for this to cool down. I guess first off, the engine is starting to smoke a little. And it's not the smell of diesel, it is the smell of oil. The other thing is that I did see it or witness it over rev for a second, and then it quickly corrected itself. So I'm not sure what to think about that. You know, are the two issues related? Not sure, but I'm going to let it run a few more minutes, see if anything changes. So yeah, the engine, it could be a little bit wounded. You know, it is still smoking. It's been another minute or so. Although it is maybe getting a little bit better. I guess the confusing thing is that it did not do this when we first started it, or when we load tested it. So I'm thinking likely it's oil in the exhaust that finally heated up and will eventually burn off, but yeah, I'm not sure I want to leave it running a whole lot longer given the amount of noise it makes and the amount of smoke it's producing. So I think we're going to shut it down. All right, guys, and that is pretty much a wrap. So this machine definitely down on horsepower a bit and not looking good as far as the amount of smoke coming out of that exhaust at the end. So, you know, the first 8 minutes, there was nothing to speak of. So, you know, potentially it was oil burning off in the exhaust, but I'm more inclined to think that we might have engine problems given that it didn't perform very well under the load test. This should have had no problem pulling 5,000 watts. And although technically it did, according to the labels on the load bank, in reality it didn't. The engine speed slowed. As a result, the voltage also dropped, and it just couldn't pull that kind of a load competently. So we backed off to 4,500 watts. Things were barely passable at about 113 volts and just about 57 hertz. So yeah, the machine definitely wounded, but it is running again. And I'm happy to see actually the generator on here is a good generator. Once we swapped out that capacitor, the voltage came up to where it should be. The THD was actually quite low. I don't think we got above 5%. So yeah, overall, not too bad. This machine living out at sea, I would say it does have a limited life, but we managed to squeeze a little bit more out of it. So I hope this video helps someone. Thanks for watching.